All right, so we've looked at determining the indices for planes and sketching planes in a unit cell. So because in directions we talked about the hexagonal system being unique and, to be honest, a little confusing and frustrating, let's go ahead and look at planes in that same context of hexagonal systems. So the takeaway here is that there's not much difference in the hexagonal system. You don't have to go through those same complications we did with directions, where you started in 3 index and you had to convert to 4 index and do all of that. Here, you can treat planes in a hexagonal system the same. You can use 3 index notation, you can use 4 index notation, either way. You can do either one of them, start with it the same way. You don't have to do anything special, and then you can also convert from one to the other very easily. So with that in mind, then we'll just go straight into the example, the question. So I've got a plane highlighted here in a hexagonal system, and I want you to determine the Miller indices for that hexagonal plane shown, and do it in both 3 index and 4 index notation so that we have an idea of that they are the same. It's the same procedure either way. So go ahead and do that. Fill it in the quiz, and come back and we'll work through this worked example. All right, so let's go ahead and work through this example. So we're trying to determine the indices of this plane, which is the same as in the previous slide. Excuse me. And we want to determine the Miller indices in both 3 index and 4 index. So I'm going to make my normal table, and I'm going to go ahead and just do all of the axes, so all 4 of them. So A1, A2, A3, and also Z. So this is going to be my little table. And the first step, so we're going to use the same procedure that we did for other planes, is we want to move it if it goes through the origin. Here, you can see that it actually doesn't go through the origin as we've defined it here. So we're good on that point. And so now we move on to the next one, which is going to be, we want to look at our intercepts, right? Number 2 is we want to determine the intercepts for each axis. So A1 is this axis, and you can see that we have an intercept right here. And so this is the origin. So this is, since it's at the edge or corner, then that means it's 1 unit. And so it's going to be 1A. All right, simple enough. So now let's look at the A2. So our A2 axis is going back into the page, and so you see that it's not going to cross that, but it is going to cross the negative, right? Since this would be the negative A2. And so you see that it's right here in the middle of that, so it's going to be minus 1/2 A. All right, move on to the next one. And we see that A3, it crosses right on the corner again, and so that would be 1 unit, so 1A again. And the z-axis, we see this is the z-axis, and again, it's kind of halfway up the z-axis, and so we're going to call that 1/2 C. So those are my intercepts with the 4. So like I said, we can do either 3 or 4. That's why I went ahead and did all 4 of them here. So let's go ahead and just look at 3 index. So for that, basically just cover up A3. So just ignore it for now, right? So what we would normally do is we've got our intercepts, and so we would take our reciprocals. So 1/1, 1 over minus 1/2, 1/1, and 1/1/2. So again, I'm just going to kind of forget that and just kind of continue to do that. So that would give me 1. This is going to be minus 2. We'll go ahead and do this one as 1. And then this one is 2. So if at this point, if I forget this one again, I've got 1, -2, and 2. Those are the smallest integers possible. So I can write it as 3 index. I'll do it over here. That would just be, again, parentheses, the first second, which is -2, so bar 2, and then 2. So I've just ignored A3, and that's my plane. But if I want the 4 index, then all I have to do is not ignore it. I've got the information here. So I'm going to have that as 1, bar 2, 1, 2. And that's it. So in this case, it's very simple. We don't have to do any conversions. We can directly use either the 3 index or the 4 index. There's no complication in that way because of the way that it's defined. So we can do either one of them from the same procedure. And one thing I want you to kind of pay attention to is if you look at this third number, you can actually do a quick check. You might remember the formula from for the third index conversion when we talked about directions. That was t equals minus u plus v. It's actually the same expression here. So this should be equal to the first two, the negative of the first two summed up. So if I take 1 plus minus 2, that gives me minus 2, and then I take the negative of it, so it's going to be 2, it should be equal, sorry, if I did that wrong. If I take 1 plus minus 2, that should be minus 1, and then if I take the negative of that, that would be 1. And so that's the same as this indice. So you can always do a quick check using this type of expression to make sure this is a valid third indice for that. But otherwise, these are the indices that we're looking for this particular plane.